In this nugget, we can continue our discussion of routing and remote access. I thought I was going to say conclude there, but guess what? We have one more nugget after this on routing and remote access. Anyway, we're going to use routing and remote access to discuss demand dial interfaces. This is going to be what we're going to do, for example. If I have two sites, maybe one's a remote site that's got a slow WAN link or an expensive WAN link, and I just want to make sure that I only use the link when I absolutely need to. And at that point, I'll configure a route that will go to the destination network, and someone tries to access that route, automatically lights up the demand dial interface. Then we can also take a look at static routing. That's going to have to be what I do in certain small networks where I need to manually determine which route to choose for certain kinds of packets for destinations. And then we'll also take a look at RIP, or Router Information Protocol. This is going to be my alternative to static routing if I ever get tired of maintaining a whole bunch of route tables manually, and if my network grows, because RIP will automatically keep track of all of my routes. However, it's also a little bit heavy on network traffic, and it does a lot of broadcasting. Now then, let's talk about another kind of a connection, and that might be where you need a demand dial connection. For example, here I've got my main office up here in Phoenix, and I've also got a satellite office down in Sierra Vista, Arizona, which is about 4 hours away down by the border of Mexico, and it's home to Fort Huachuca, which is an Army intelligence base, a big Army intelligence base, and where they have a lot of secret things that go on down. In fact, I used to live down there, and I used to have a friend that worked on the base, and he did some kind of intelligence training. I asked him one day what he did, and he couldn't even tell me the field he was in, whether it was in administration or computers, or whether he was a pencil sharpener, whatever he did. Anyway, he couldn't even tell me what he did, so secret. That's also where they do the training for the interrogators, for people that do Army interrogations, although I don't think they call them interrogations anymore. I think they're called interviews now. Anyway, as daunting as that sounds, it's really in a beautiful area. This is the Huachuca Mountains, where Fort Huachuca is located. And if you look at my mouse pointer, it's just off to the right over here somewhere, which would be to the north of what you're seeing there. And then just to the left down here is Coronado National Forest, to the south, real close to Mexico, where Coronado came up through Mexico into Arizona. Anyway, we have here a connection from Phoenix to Sierra Vista, and we're really cheap. We don't have a lot of money, and we don't really need a lot of connection here because we only have a connection periodically. We only need a 56K modem periodically so that we can do some replication with Active Directory every night, and so we can get some occasional access to resources down in Arizona. So no way in the world we're going to pay for a T1 line here, or even a fractional T1. Just this modem connection will be just fine. And what we can do with that then is we could go to routing and remote access and configure a demand dial interface. Notice where I am. I'm in the network interfaces node here. And I can right click and choose a new demand dial interface and then go ahead and click on next to create the connection. And here's where we start the wizard. You need to enter in an interface name, and I usually name this something that's fairly intuitive that identifies what I'm connecting to. I'm connecting to a modem in Sierra Vista, so I'll just type SV for Sierra Vista. Plus, that's a lot of spelling if I type the whole thing out, so I'm just going to leave it at SV. And then I'm going to connect using a modem, ISDN adapter, some other physical device. A modem or ISDN adapter will be pretty much the same thing, because as soon as I click on next, it identifies the hardware, the modems that I'll be using to make those connections, whether it's an ISDN adapter or whatever. And then here's the VPN connection. You can also do that for PPTP or L2TP connections, or point-to-point protocol over Internet. Ethernet, excuse me. I'm going to go ahead and use my modem connections, and I'll just connect on COM1 here with this 56K modem, and I'll connect to 520.555.1234. So I think it's area code 520. They might have changed it anyway. I'll give the rest of this as a Hollywood phone number, you know, the 555 prefix, so that nobody can actually call anybody on that number. And then we'll go ahead and check all that apply in terms of the protocols and the routes that we want to use. I'm going to route IP packets on the interface so that when I try to make a connection to a specific network ID, it automatically lights up this demand dial connection, dials out, and completes the connection. We can also add a user account so that not only can we in Phoenix dial out to those in Sierra Vista, that modem down there, but also if someone in Sierra Vista wants to dial out to us, we will allow them to do so. And you can send a plain text password. Needless to say, that's not that secure. And you can also use some scripting. A lot of times a modem will need additional commands along with its connection, and you can add scripts for that kind of a thing, or if you need to make any other kinds of modifications to that connection. Here I'll simply enter in the static route for that remote network. So what this is saying then is anybody who on my network tries to, ping or access a web page or a server or anything that's on a 192.168.6 network, then what's going to happen is it's automatically going to light up this demand dial connection. So I've got that connection there, that route there. Click on next. It'll enter in a password, because what's going to happen now is I'm going to create a account on this local system here. Now, this is not going to be an Active Directory account. It's just a local account that's going to appear. If I go to Computer Management and go to Users and Groups, it'll appear right there. And I'll just enter in a password and click on Next. And then we need to enter in a password for the dial-out credentials as well. Now, the previous interface was the credentials that are going to be used when someone in Sierra Vista calls into us. What I did in that previous interface, let me just go back real quick, is I created an account here locally for them to use for credential checking when they attempt to contact my modem. Next thing I'll do is to enter in the credentials that I'm going to use to contact their modem down there. And of course, this means I have to coordinate this with whoever the administrator is down there. Now, I'll just name this one Phoenix, and of course there will be an account called Phoenix down in the Sierra Vista organizational location. Now, what I'm also doing here is I'm not entering in a domain, and you just leave that blank because I'm not actually creating this in a domain. I'm creating this on a local routing and remote access server along with the password credentials that I entered in there. And then I just click on Finish. That's pretty much it. Now I've got a Sierra Vista demand dial connection through that modem, and as soon as someone tries to access that static route, anything in that static route range that I created there, it'll automatically heat up this connection and we'll dial down there. Now, I've gone ahead and deleted that demand dial connection using a modem. What if we have upgraded that link to Sierra Vista? Now we have a 512 kilobit per second internet connection between the sites, or maybe dedicated WAN link. Either way, maybe we want to secure that connection. Well, we can do that by now creating a new demand dial interface that doesn't use a modem. Instead, it's going to use an existing network connection. And we'll go ahead and click a demand dial interface here to make this now a virtual private network connection. Again, I can just name it Sierra Vista or whatever I want to name it here, and then we'll create a virtual private network connection to that destination instead of using a modem or something like that. And I'm going to go ahead and use Layer 2 tunneling protocol as a more secure method for this, so I'll go ahead and click Next here. And I'll enter in the IP address of the interface that's receiving traffic down there on that end. So if, for example, it's a dedicated WAN link, then we might still use a private IP address on this dedicated WAN link, so it might be 192.168.1.1, let's say, and then hit Next. And then I'll route IP packets on that interface and add a user account. I can just add this range, or this network ID. And we'll go ahead and click on Next. Now, let me point something else out about the dial-in credentials that we're going to be using here. The reason why we're entering in these credentials is because this is going to help to prevent the router from being confused and thinking that this connection that's going to be made is just an ordinary L2TP connection from some actual user, from Joe User down in Sierra Vista. By setting it up this way within this wizard and creating this account here, we're designating to the routing and remote access that anytime this account connects, that it's actually going to be coming from a demand dial connection. And the same will be true on the other side when we create this other account that creates the opposite, or that connects the opposite direction. So then we'll go ahead and click on Next, and then we click Finish, and that's pretty much it. Now we have a new demand dial connection that uses L2TP. We can right-click here, choose Set Credentials to change the credentials if necessary, or to reset the password. We can just go ahead and connect it. We can disable it. You can also set up IP demand filters. This is very handy, once again, if you want to restrict the type of traffic that comes through, or you want to restrict it only to or from certain IP addresses that you want to be able to make this connection. And then we can also set the dial-out hour, so maybe we only want this to be used during certain periods at night while we're having some kind of replication going on between a database or something like that. Now, another possibility with a connection like this, especially a VPN connection that's already using an existing turned-on link, is you could go to the properties here and go to options and make this just a persistent connection. That way, instead of using a demand dial connection that might disconnect after 5 minutes or something like that, well, let's make it persistent, and it's just always going to be on. Then if it ever does disconnect, for some reason accidentally or a network interruption of some kind, we can still have it redial a certain number of times. Now, I didn't point this out with the modem connection that I created a little while ago, but you could also create a callback item here so that we configure this outbound connection over VPN, and then we configure it to call back on an ISDN line or a modem line like this or something like that. We could have also done the same thing with the modem in the first place. Dial out on a modem, and then when the receiving RRAS server answers, it'll then hang up and dial back again to this same site here. And the purpose for doing that once again, as I mentioned a little while earlier, in a previous section was so we don't have somebody calling in from somewhere else that's not really in Sierra Vista. So we can help to prevent imposters. And then we'll go to the Security tab here, where you can, again, configure additional settings if necessary. In order to do that, you might have to go down to the Advanced Settings down here and custom configure the authentication protocols that you need and so forth. And then, of course, we have our networking selection where we've already chosen to use L2TP using IPsec. Now let's also take a look at some characteristics of this account of this connection by right-clicking and choosing Set Credentials. Now here, if I had the name of the account being Phoenix, if it would change down there in Sierra Vista where I'm trying to make the connection to that remote router, then I would make the changes here as well. For example, maybe we'd change the password down in Phoenix for security purposes. Well, I would have to manually change it up here as well. And again, this is going to be credentials that appear on that remote router. There's not a Phoenix account on this local system. On this local system, I do have an SV account. And by the way, the actual interface here, this demand dial interface of SV, must have an exactly matching account so that if I go into my computer properties here, or actually my computer management, and go into the local users and groups, I should have a user account that exactly matches the demand dial interface right here. That's important to remember because otherwise, these RAS servers, especially if they're already also configured to accept remote access clients, just normal VPN connections from users, then it's going to confuse the connection and think that it's just a normal RAS client. That way, it's going to make a connection, but it will not be able to transmit any data over that connection. But by naming the account the same as the actual demand dial connection itself, you'll be okay. Also, of course, you can make a manual connection. You can also disable this connection if you need to do so for troubleshooting, or if you're concerned that someone's trying to hack this connection or hijack it somehow, you can just disable it. You can also set up demand dial filters, set IP demand dial filters, and that brings us to this familiar interface. And you have to specify, for example, what kind of traffic we want to be able to accept. So you just click on New, and you saw us use some of this earlier, so you could just configure that as necessary for your own purposes. And you can also configure the dial out hours. Maybe you only want this WAN connection or this demand dial connection to be used at night so that it can transmit some SQL database replication, or it can transmit some Active Directory replication or something like that. So we might deny everything and only allow connections, on weekdays during these hours at night. And then that would be a way that we can make that work as well. Now let's take a look at a static routing situation where static routing would be ideal. And that's what we've got in this situation because we've got less than 10 segments here. We've got a pretty simple configuration. Traffic has a tendency to flow in a single direction without any complications. And if we don't expect a lot of changes, then static routes would be just fine here when we wouldn't need the overhead of a routing protocol like RIP or OSPF, which we'll discuss later and which are ideally suited for other situations. In any case, what we have here is really traffic going pretty much one direction. If I have a client on subnet A that needs to talk to subnet B, they can do that because they go right through their own configured default gateway at 10.10.8.2, which passes it on to the output of 10.10.9.1, places the packets on this network. Likewise, anybody on this network that needs to talk to subnet C, they can do so because they'll go into this interface at 10.9.2 and goes out of 10.10.10.1, places the packets on this network. And then finally, if someone on this network needs to communicate on the internet, well, they could go through this router because it will be placed onto this interface here, which is going to be their configured default gateway for any clients on this network. And it'll go out of this network card out here, out to the internet. So it's a pretty straightforward single direction network, but that's also the problem. It's only going one direction. What if I got a client over here that needs to talk to a mail server clear over here in subnet A? Well, we can only go one direction because we have our configured default gateway here at 10.10.10.2. So what's going to happen now is this client is going to try to communicate with 10.10.8.20, and it's going to just go through this configured default gateway, which is going to send it out to the internet, and it's going to crash and burn the first internet router it hits because it's a private IP address, and the mail server isn't out there anyway, so there's nothing to find. So what we're seeing here is our fish are all swimming downstream, and what we need to do is to get these fish, or our packets, to swim upstream the opposite direction. And we're going to be able to do that by using only 3 simple static routes. Now then, in order to resolve this problem, what I'm going to need to do is to create those static routes, and here's how they're going to look. You can use this, you can create the static routes using the routing remote access interface, or you can use the route add command from a command line. Either way, this is the basic idea of what they're trying to do. My router C-INT router over here is going to create two static routes. The first one is going to look like this. Anytime you want to try to communicate to 10.10.9.0, anytime you want to communicate on this subnet over here with this subnet mask, and you have to identify the subnet mask as well in the route, then we're going to communicate on this interface. In other words, this interface right here, and it's going to point it to a gateway over here on router BC. Now, router BC will then be able to forward that packet directly onto 10.10.9.2 because it knows about that network right here. The second route I need to configure is almost identical. The only difference is I'm going to specify in the destination .8.0 instead over here on router C-INT. It's going to use the same interface to send the packet out. It's going to use the same default, or rather the same gateway over here at 10.10.10.1. And this server here, this router B-C, it will then be requested to forward that packet out. However, if it doesn't know anything about this network over here, it's not going to be able to forward that packet. So that's where it comes into play, where I've got now my router BC static route that will configure on this server. And for that one, I'm going to designate a destination again here of .8.0, and I'm going to give it a subnet mask of 255.255.255, or a Class C subnet mask. And then the interface of 10.10.9.2, and that's where we're going to direct that traffic, and then this interface here is going to forward those packets on to 10.10.9.1, as you can see down here. And then from that point, this router here has direct knowledge of 10.10.8.0, and the packets will be able to go over here. Now, having done something like that, we'll now be able to have packets going both directions, both their normal downstream flow over here, as well as kind of an upstream flow because of all the static routes that we'll now configure to get clear over to 10.8.0, 10.10.8.0 if we need to. Now, from within routing and remote access, how do I go ahead and configure a static route? Well, here I'm almost in the same situation I am right now, except that my IP address on my local host here is actually .20 over here on this interface. But anyway, other than that, I got the same IP address here, same IP address here. If I needed to communicate with 10.10.9.0 over here somehow, how would I configure that within routing and remote access? Well, what I would do is to right-click here, choose a new static route, and then I would designate the interface that it's going out of, and in this case, it's going out of this IP address, which is called my private network interface. So that's what we've got here, private network. And the destination would be 10.10.9.0 with a 255.255.255.0 network mask. And then I configure a gateway here as well of 10.10.10.1. And that would kind of correspond with what you see here. It would correspond with that gateway on router B and C. Now, having done that, let's go ahead and take a look at something else here as well. We have this metric idea here. Now, we've talked about that a little bit in the past. Again, the metric, the lower the number, the more preferred that route will be. So if I had a situation where I perhaps had two routers, a more complex situation where I had another router down here, and I could go from this host down to this router down here, and then connect this router up to this same network, then maybe this was a less preferred route. Maybe it's a slower router, or it's got some other kind of a handicap of some kind, or I just don't prefer it. Well, I could configure it with a higher metric, maybe of 5 or something like that. And in that case, it would prefer at all times to go to this interface unless this was not responding or the server was down or something like that, and then it would go to this metric of 5 where I've got it here. In our case, we got a pretty simple configuration, so I'll just click OK and leave it at 1. And then here's the actual route itself that appears. If you need to make changes, of course, just double-click on it and make whatever changes are necessary. Now, you may also want to know that this will be a persistent static route so that it will survive a reboot. And I can confirm that for sure because as soon as I added that static route, you didn't see this, but as soon as I added that static route, for some reason, this Windows Server 2003 server rebooted spontaneously. And they say Windows Server 2003 is so stable, I tell you. And actually it is, to be fair, but for some reason it just rebooted on me. Anyway, let's go ahead and take a look at something else important as well. I'm going to show you some other ways of adding a static route. But in order to do that properly, we first need to understand the route table. And to see the route table, there's a couple of different ways of doing it. I like to just go route print. I just like the command line version of this. And when you do that, it'll show you the active routes that you have here. It also shows you a list of interfaces that you have in here. 0x1 is, of course, our hex number. 0x1 through 0x9, by the way, in case you don't know. are the decimal equivalents of just normal 1 through 9. And then once you get into these kind of numbers down here, you'll have to use your handy little calculator, and you can use it in scientific view to convert between hex and decimal. Now, having cleared the screen here, let me just show you why you'd need to know about those interface numbers. You don't really need them very often, but if you do a route, and then you make an addition here, route add, and I'm just going to press enter here, which shows you the online help system. It's going to show you that you can add an interface. This is not an operator, it's not if, it's an interface of number 2. So that would have been 0x2 in the route table. For 1, which would have been our loopback address, you'd put a 1 there. Then you'd use your handy little calculator to calculate the number that you want to use for any of the others. And by the way, you can put both a decimal number there if you want, or you can also put the hex number. It'll interpret both of them. Now, just quickly, another way to access the same routing table, only there's a little bit of an additional benefit with this, is you can do it in the GUI through routing and remote access by right-clicking on static routes and showing the IP routing table from this menu. The thing I like about this, if you want to use it, is that the interface identifies what you actually named it, instead of giving the IP address. Instead of giving me just 10.10.10.20 here, it gives me the name of the interface. For me, it's just more confusing. I'd rather just work with the IP addresses, so that's why I stick with this. In any case, let's go ahead and take a look at what these things are. You're going to need to be able to understand this route table and be able to identify what each line means just cold. You need to understand this very clearly. First of all, there's the default route, which normally appears at the top here. All zeros for the network destination, all zeros for the network mask. That's just the default route, and it's used when there are no other matches that are found in the routing table. So if I were to ping, for example, for 137.128.9.2, well, there's no destination for that here, so it's going to go to the default route here, send it out through this interface, 10.10.10.20, and destined for the 10.10.10.1 gateway, and then that actually is a router to the internet, and that would then find the address if it's available out there. The next thing we see here is anything for the 10.10.9.0 network. Does that look familiar? Yeah, that's the one I just added. And then it gives us the 255.255.255.0 network mask, and that's what we, of course, entered in our interface previously. It sends it out through this interface, once again, this time with a metric of 1, so it's a pretty preferred metric there, and it'll send it also out to 10.10.10.1. And then here I've got a 10.10.10.0 with a Class C subnet mask. And the reason why we have this is because I've got that IP configuration on my network card at 10.10.10.20 with a Class C network subnet mask. And because of that, it creates this entry in the table. And we also see a similar thing for our 66.224.47.0 address as well. Now, with this one, it knows that it's within its own broadcast range, so it uses as its gateway out of its interface of .20, uses as its gateway the same address, because it knows it's within the broadcast range, so it's not going to forward it on to a router somewhere. And then again, we have a metric of 20 on that one as well. Then this one is more specific, 10.10.10.20, which is my own IP address here. It has a network mask of all turned on, all bits turned on. And this identifies it, because all these bits are turned on, identifies it as what we call a host route. And with the host route, we notice its own IP address, therefore it's just going to send it back to its own loopback address. It actually never even hits the hardware, never actually hits the wire. It just loops it back within the software and returns it to the local client here. Now, that also kind of begs a question. You see, we've got this specific IP address here, but we also have a network destination of 10.10.10.0. Why did it use this location here in the loopback instead of using this location here and sending it out through the physical network card? So how do we know which one's going to win? Well, in this case, it uses what we call the largest match. You see, in this one, we only have the first 3 octets turned on in the bit mask. In this last one, we have all bits turned on, and so that's a larger match because it matches further into the last octet. Therefore, that makes this, if we look at it in binary, makes this a larger match. Therefore, since it's more correct or more better, if you will, then we're just going to go ahead and use the loopback address there. So now here we have all 255, and that can identify one of two things, like I said, with the host route. It can identify a specific host, like with this .20, and it can also identify a broadcast. So in this case, in the next line, 10.255.255.255 represents a broadcast, which means that anytime it looks for anything starting with 10 dot now, it'll just broadcast it on this same gateway interface, again, of .20. And then we see the exact same kind of an idea duplicated for the 66 network that we see down here. Same idea all the way across. And then we have a loopback address, which is always going to be there as well. Anything going to 127 dot whatever is always going to come back to the loopback address that we see here. And then these last entries are multicasting addresses. Anything that starts with a 224 is going to be multicast because the last normal IP addresses you can use are 223 dot. So with this one, it's going to use a network mask of 240, and it's going to send any multicast requests out through, again, 10.10.10.20. Now, for multicasting, it'll also send out multicasts out through the other interface that we have here as well. And then for any broadcast that we have, it's also going to send that out through both interfaces that we see down here. Because all 255 means an all broadcast, so it's going to either use 10.10.10.20, actually it's going to use both 10.10.10.20, and 66.224.47.1 for all broadcasts. Now let me point out that we actually also have two broadcasts going on here. Actually, we have more than two. I guess we have four. We have this broadcast here on the 10 dot, and then all broadcast for the rest of it. Anything that ends in 255, by the way, is always going to be a broadcast. So this is a broadcast here at 10 dot, this is a broadcast here at 66 dot, and this is a broadcast with all 255s. Now, what's called a limited broadcast address is one that uses all 255s, so these are both limited broadcast addresses. And these are specific broadcast addresses when they start off with a specific network and then end in 255. Now here I've entered in a command line function to add another route. This is now, of course, not using the GUI. I'm just going to use the interface here. This will not be a persistent route. This will not survive a reboot. I'll just route add 10.10.8.0. That's the network I'm trying to reach. And then the mask I'm going to use is a Class C subnet mask, and this is the gateway that we're going to be using to make this connection. And I'll press enter, and then do another route print to confirm that it has appeared correctly in the route table. And we see that up here again at the top, 10.10.8.0, subnet mask of Class C, and a gateway of 10.10.10.1. So that's what we want. Now what I actually want to do is to make that a persistent route. So in order to do that, I first have to delete this route, and I'll do that by typing in route delete, and then you just enter in enough information to identify the network destination, 10.10.8.0, and then I'll press enter, and it has now deleted that, which I'll confirm by doing another route print, and we don't see it there anymore. Then the next thing I'll do is I'll use my arrows to cycle through so I don't have to type so much. There we go. That gives me back my original route add, and to make that persistent, I'm going to do a -P now and press enter, and then now when I do a route print, then we're going to see that I now have a persistent route listed down here at the bottom, and that will survive a reboot. Now, one thing to keep in mind here as well is that this route will also appear in the GUI. If I right-click on static routes and again show the IP routing table, we see that we got the 10.10.8 route there, but there's nothing in the interface there that shows whether or not that is a persistent route for us. And in fact, if I also go to the static routes here and refresh the screen, I don't see a static route appear here for 10.10.8.0. So, what I recommend you do is use one or the other. Use all static routes and all interface like this, what we got right here, or use all command line here, because otherwise you could really get into an uncertain situation whether you're not sure if you've got an IP route listed or not. Now, sometimes you'll get complaints from users where they'll say, we use our dial-up connection to connect to the RRAS server, and as soon as we get to the RRAS server, we can see resources on the RRAS server, but we can't get access to the rest of the network for where the file server is, the SQL server, the mail server, all that stuff. Why not? Well, that could have something to do with the fact that this is misconfigured. When you right-click on the server and choose properties, it might have cleared this router item, or somebody might have gone in and cleared that for some reason. Or they might have chosen to do a local area network routing only, and if you've got a demand dial connection that's trying to come in from a branch office and they're not able to see resources on the rest of the network, then that's probably because someone has deselected this radio button, and for that you'll need to allow demand dial routing. And then for that other network, they'll be able to see resources inside your network as well. The other place you'd want to go for this is to go to the general item down here and select whichever interface it is that you're interested in routing for, and go to its properties and make sure that it has this selected checkbox for Enable IP Router Manager. And again, that will then allow it to route through that interface. Now, if you find that your network is growing and you're getting closer to like a medium-sized network and you're having to do a lot of static route maintenance, and it gets to be a little bit out of hand administratively, you might want to consider using RIP instead, which is great for small to medium-sized networks, as long as you keep within about 15 routers or less. And the advantage of RIP is twofold, really. Number one, it's very easy to deploy. You can do it within like 30 seconds. And number two is that it updates itself so that you don't have to do any more manual configuration, although you can still do manual configuration if you want. And then in order to install RIP, which is the Routing Information Protocol, I'd right-click here on the General item, choose New Routing Protocol to select RIP version 2 for an Internet Protocol, and click OK. Once I've done that, I got this RIP item down here. Now I need to specify which interface I want to configure RIP on. So I'll choose right-click here and choose New Interface. Specify which one I want. I'll just choose the private network in this case, which leaves me with this dialog box from which I can configure RIP. Now with the operation mode we have here of periodic update mode, this is the default setting for LAN connections. And what happens is every 30 seconds, this RIP property will just broadcast to everybody else on the network all of the routes that it knows about. And it's pretty chatty that way. It's kind of like my mother-in-law. The other day I was in the hospital visiting a relative, and my mother-in-law was there with me. And this guy walks by, and she just stops him, introduces me. Hey, this is James. Say hi to James. And I shake this guy's hand. He's got kind of a blank look on his face, and then he walks off. And then it turned out the reason why he had the blank look on his face was he didn't even speak English. Well, my mother-in-law didn't care. She just has to introduce me to everybody. I don't know. She must be very proud of me or something like that. Anyway, so now I feel kind of guilty about talking about her that way. But anyway, hopefully she'll never hear this recording. Well, that's what periodic update mode is like. It just broadcasts to everybody on the network and says, hey, I know this router. Hey, I know that router. And it just introduces everybody over and over again every 30 seconds. And like those brief introductions that you get with people that you probably never see again in your life, periodic update mode quickly forgets about who it's been introduced to if it has to restart or if the service restarts, because then it just clears out the routing table, rebuilds it again from scratch. But never fear, 30 seconds later it'll know all the routes again. The other thing with this is you could use auto static update mode, and this is the default setting for demand dial interfaces. With this, it only advertises its routes when it's been requested. So it's not going to just constantly chat this every 30 seconds. And then the auto-static updates that are made are going to be static entries in the routing table, and they never actually go away even if the service is restarted or the server reboots until someone actually deletes those routes. Now then, for the outgoing packet protocols, you can choose for compatibility purposes to go back to RIP version 1, or you can also go to RIP version 2 multicast. This would be very handy because it's going to use quite a lot less network traffic than this very chatty and frequent broadcast that takes place. You can also do silent RIP, which means that this interface will only listen to broadcast announcements for RIP, but it will not send out any announcements of its own route tables. And then for the incoming packet protocol, you can again choose whatever is necessary there for compatibility purposes. And you can increase the cost for the route. Maybe I wanted to increase that to 2. And that'll add 2 any routes that it learns of. It'll add the number 2 instead of 1. That will make then certain routes less attractive in terms of the routing cost. And you can also add a tag number here for announced routes to identify certain parts of the network. Now, here's what I really want to get to. Activate authentication. You can use a password here, and with this password, only routers that share the same password will be able to share their announcements. Any RIP announcements that don't match whatever password I type in here is just going to be discarded. Now the thing you got to keep in mind with this, however, is that it's very rudimentary security. In fact, it's almost no security whatsoever. Because the password, like many other things we've talked about in this whole series, is sent over the wire in the clear. So any, 8th grader with a packet sniffer on the wire is going to be able to figure out what the password is, and then they'll be able to exploit that. Now here on the Security tab, you can also specify whether you really want to accept all routes for incoming routes. I mean, you can narrow that down. That'll help to cut down on the router advertisements accepted by this server. And it'll also make sure that we only receive advertised announcements from certain routers that we really want to receive them from. You can accept all routes in the ranges listed, then you'll just enter in a range in this, and it's pretty simple to do. You just enter in the IP range. Or you can do the converse and then just ignore all routes in the ranges that you list down here as well. Now on the Security tab, you can specify if you want to accept all routes from all incoming routes here, or you can specify all routes in the range listed down here. And that might be useful if, for example, I know that this router is only going to be able to communicate on a certain range of subnets anyway, then I'll just enter that in here, and I will just disregard then any of the routes that it wouldn't be able to contact in any case. And conversely, I could also just ignore all routes in the range listed here as well. And then for the neighbors item here, I can use broadcast or multicast, which is the default anyway. Or I can use neighbors instead of broadcast or multicast, and that will then become unicast. Then I'm only going to announce my routing table to specific IP addresses that I list down here, or I can use a combination of both neighbors in addition to broadcast or multicast. In this nugget, we discussed routing and remote access, and this was part 4 where we started off with a discussion of demand dial routing. And this is very useful if I have two sites that are separated by a slow or an expensive WAN link, or if I just don't want the link on all the time. Maybe I only have synchronization that takes place at certain times during the night. Well, I can schedule that and make it available during certain times, and when someone tries to access that remote route, then it will light up that demand dial connection. We also saw that with static routing in place, you can configure routes to different networks besides what the natural path of the network flow might be. And this will be useful especially in smaller networks where you can easily set up static routes. However, as the network grows, you might need to use router information protocol or routing information protocol. And this is useful because it'll automatically detect changes in the routes, but it's also a little chatty because it broadcasts the entire routing table every 30 seconds. I hope this has been informative for you, and I'd like to thank you for viewing.